Welcome to this video tutorial from spssvideotutor.com. I'm Jacob Mays, and today I'm going to demonstrate how to perform and interpret a one-way analysis of variance. In this demonstration, I will use a data file called the 1991 U.S. General Social Survey. You can find it in the SPSS sample data folder. Let's begin by examining if there is a difference in occupational prestige among respondents from three regions. In this example, occupational prestige is the dependent variable and region is the independent variable. Region has three factors: northeast, southeast, and west. Just to clarify, occupational prestige scores reflect the level of social status and income associated with a person's job. So a doctor would have a high occupational prestige score, while a street sweeper would have a low occupational prestige score. The first step is to go to Analyze, then Compare Means, and then down to One-Way ANOVA. Next, we go and we find occupational prestige score, and we move it into the dependents list. Following this, we go to region and we move the region variable, which is our independent variable, into the factor box. Okay. Next, we go to options and we select descriptives, homogeneity of variance, and Brown-Forsyth. Okay. For missing values, make sure Exclude Cases Analysis by Analysis is selected, then click Continue. Next, we go to Post Hoc and we select Tukey under Equal Variances Assumed, and then under Equal Variances Not Assumed, we select Games-Howell. We click Continue and then click OK. Now let's review the results of the ANOVA in the SPSS output window. Okay, the first thing we see always is our syntax that was actually executed for this analysis. Okay. Second, we see the descriptives table, and this gives us information about each group, including the number of cases in each group, the mean scores of each group, and the standard deviation, standard error, and so on and so forth. Okay. The second table that we see is labeled the test of homogeneity of variance, and this displays Levine's test for homogeneity of variance. This tests whether the variances in scores is the same for each of the three regional groups. All this means is that the absolute difference between the mean and raw scores of each group need to be generally the same across all groups. If the significance value is 0.05 or greater, then you have not violated the assumption of homogeneity of variance. If this value were less than 0.05, then the assumption of homogeneity of variance is violated, and you will need to use the table labeled robust test of equality of means instead of the ANOVA table. In the ANOVA table, the main thing we are interested in is the significance value, right? So this right here. If the significance value is less than 0.05, then there is a significant difference somewhere among the mean scores of the independent variable region. Okay? It's important to note that this does not tell us which groups are different from each other. For that, we have to look at the table labeled multiple comparisons. Okay? Now, if the assumption around homogeneity of variance was violated, meaning if this were less than 0.05, then we would use this table instead of the ANOVA table. We only look at the multiple comparison table if we find the significance value is less than 0.05 for the ANOVA or the robust test of equality of means. If the variances are equal, we use Tukey's HSD. If they are not equal, we use the Games-Howell test. Okay, so we look down the column labeled mean differences and look for any asterisks next to the values listed. Okay, so we have one here between the West and the Southeast. Okay, wherever you see an asterisk, this means that the two groups being compared are significantly different from one another at the p less than 0.05 level. Therefore, we see that the respondents in the Southeast region have significantly different occupational prestige scores than those in the West. Okay? So if we go back up to the top, the mean occupational prestige score for the West is 43.82, and for the East, it's 41.58. Therefore, based on the results of the ANOVA, the West has significantly higher occupational prestige scores than the East.
Okay, so after you have interpreted your results, the final step is to report the results in APA format. So here we have the title page, and we have the running head, which is simply an abbreviated title that explains what your analysis or report or study is about. And then we have the page number over here, and you can see an example of this on page 41 in the APA Manual 6th edition. Alright, so you have your title, your name, and your educational institution. And then you have results, and then the first thing that you want to do is you want to specify the test that was performed and the purpose of the test. Okay, keep in mind that you must always write your results in past tense. Alright, so a one-way analysis of variance was conducted to assess if there were differences in occupational prestige scores among respondents from 3 U.S. regions: Northeast, Southeast, and West. Next, you want to describe the independent and dependent variables in detail. The independent categorical variable was region, and the 3 categories were Northeast, Southeast, and West. The dependent continuous variable was occupational prestige scores, where scores range from 17 to 86. And we got that from our descriptives table, where we looked at the minimum, and the lowest minimum is 17 and the highest maximum is 86. Alright, then we indicate what high scores and low scores mean if it isn't obvious, or if the test isn't popular or well known. Increasing values on occupational prestige indicated higher levels of occupational prestige, while decreasing values indicated lower occupational prestige. Alright, so then in the next paragraph we state the null and alternative hypotheses. Now, I'm stating both in written form and in notation, mathematical notation, so that you have examples for both. The null hypothesis states that there are no significant differences in occupational prestige scores among the 3 regions. The alternative hypothesis states that there are significant differences in occupational prestige scores among the 3 regions. So the null hypothesis always states that there are no differences, and the alternative hypothesis states that there are differences. Okay? Now, here is the mathematical notation. H sub O, mu1 equals mu2 equals mu3. Now, I have the 1 here, but if you only have one hypothesis, then you can exclude the 1. So it's just H sub O and H sub 1. Okay, you can just delete the 1. But if you have more than one hypothesis, then you would just have 1. And then if for the second hypothesis, you would have H sub O 2, H sub 1 2. Okay, and so on and so forth. Alright? Next, you want to report the significance of the test. And the first thing that you're going to report on is Levene's test of homogeneity of variance. Okay? This is very important. If Levene's test is not significant, you don't have to report the results. Okay? You can simply say that there were no violations in the assumption of equality of variances, or you can just skip it altogether. Okay? But in this case, I just wanted to do this or illustrate it for demonstration purposes. Levine's test of homogeneity of variance was conducted to evaluate the assumption of equality of variances. The results of Levine's test were not significant. Okay? Now, you could just simply leave it there and then move on. But what I wanted to do is I wanted to show you the notation so that if it was significant, you would know how to write it. So you would only write this if the P was less than 0.05. Okay? Next, you want to state the results of the ANOVA. The one-way analysis of variance was statistically significant. F, degrees of freedom 2, degrees of freedom 1415. Okay, so this is degrees of freedom 1, and this is degrees of freedom 2, and you get that. And this is the actual F value and the P value. And you get all of this information from this table here, the ANOVA table. So degrees of freedom between groups is 1, within groups is 2. The F value is 3.10, and the significance level is P equals 0.045. Okay? Okay. And then eta squared, I will show you how to calculate that. The eta squared effect size was 0.82, indicating that region had a large effect on prestige scores. Using conventional guidelines, Cohen, 1988. And I have the reference for Cohen down here that you can use. Given that the one-way analysis of variance was significant, we reject the null hypothesis. Now remember, the ANOVA only tells us if there is a significant difference. It doesn't tell us where the differences lie, so we have to report on the post hoc test. So next, you just state which of the post hoc tests were performed. Post hoc comparisons using Tukey's HSD test were conducted. Report the significance of the post hoc test. The results indicated that the mean scores for occupational prestige among respondents in the West, mean 43.92, standard deviation equals 13.3, were significantly higher than the occupational prestige mean scores in the Southeast. Mean equals 41.58, standard deviation equals 12.55. The Northeast, mean equals 43.70, standard deviation 13.29, mean scores on occupational prestige were not significantly different than those in the Southeast and the West. Now, once you've stated the mean scores, you don't have to repeat them if you repeat the group again because you've already stated them. Another thing, whenever you write means and standard deviations, you always have to italicize the M and the SD. So anytime you have a statistical symbol, P, F, eta squared, or anything like that, you always italicize that letter or those symbols, mathematical symbols. All right, and then we say, look at table 1. Now this is the table that you can use for your analysis of variance. You have the 3 groups at the top. You have the N for the 3 groups. You have the mean and standard deviation all italicized, and then you have the values here. Okay, then you have eta squared. Then you have the degrees of freedom in these boxes here. Now, wherever there's an A, that means that those two means are significantly different. So if there were differences in Northeast and Southeast, then you would simply write a B here and a B after the A. Okay? Because I have notation, means in a row sharing subscripts are significantly different from one another. So that is how you indicate if mean scores are actually different. And then here you have an asterisk, which means that P is less than 0.05, 2 asterisks means it's less than 0.01, and 3 asterisks means it's less than 0.001. Okay? Now, if you have 4 groups, then you can use this table right here. But typically you're only going to have 3, but I wanted to provide that for you so that you could have it. All right? Now, you will have an effect size calculator in an Excel spreadsheet. And essentially the way that you calculate the effect size or eta squared for the between groups ANOVA is by clicking on the Between Groups ANOVA and then putting in the sum of squares from the between in this box and then the sum of squares total in this box. And then you will get eta squared. Okay? So where do I get this information? Sum of squares between 1056.430 and then the total 241965.769. You put those there and you get 0.82. Okay, this is analogous to the r squared. All right, so in order to get the percent of variance explained, you simply move it 2 decimal places to the right. All right, so anything under 0.06 is considered small. Anything between 0.06 to 0.13 is considered moderate, and anything 0.14 and above is considered a large effect, and we have 0.82. Okay, so that is essentially how you write your results section. If you have any questions, please submit them to help@spssvideotutor@gmail.com. This has been a video tutorial from spssvideotutor.com. Thank you for watching and much success with SPSS.